So welcome to our notes for polynomial long division. And before we get started looking at dividing polynomials, we're just going to review real quick just how to divide integers. So if I want to divide 150 by 2, then 2 is called the divisor, and 150 would be my dividend, right? And I would ask myself in this algorithm for long division, how many times can I divide 2 into 1, right? The first place value here. And the answer to that is 0, right? So then I would move over a place value and ask myself, how many times can I divide 2 evenly into 15? And that answer is 7. So I would write that in the place value up above, and then I would multiply 7 times the divisor of 2. 7 times 2 is 14, and then that gets written underneath. And then I draw a line and I change the sign. So I subtract, and then 15 minus 14 is 1. And then I bring down the next place value and I repeat that algorithm. An algorithm is just a series of steps. So then I'm going back to that first step where I ask myself, how many times can I divide 2 evenly into 10? And that answer is 5. So I write a 5 up above that place value, and then I'm going to multiply 5 times the divisor of 2, and that product is 10. So I write that at the bottom, and then I draw a line, I change the sign to subtraction, and 10 minus 10 is 0, right? So that means that 2 divides into 150 75 times evenly, right? Because my remainder is 0. And is 2 then a factor of 150? And the answer is yes, and that's because 2 times 75 is equal to exactly 150. There's no remainder. The remainder down here is 0. So since 2 divides evenly into 150, the remainder is 0. 2 is a factor of 150. Okay, if I look at dividing 7 into 150, so 7 is my divisor, 150 is my dividend, right? And I repeat that same algorithm again. So does 7 divide evenly into 1? No. Then I look the next place value over. How many times does 7 divide evenly into 15? And that would be 2 times. 2 times 7, I multiply and write that product underneath. Draw a line, change the sign to subtraction, and 15 minus 14 is 1. Then I bring down the next place value and I repeat that algorithm. So I ask myself, how many times will 7 divide evenly into 10? And that answer is 1. So I write that up with the quotient and then multiply. 1 times 7 is 7. Draw a line, change the sign to subtraction, and 10 minus 7 rather is 3. And 3 then is my remainder. Now, that means that 7 is not a factor of 150, right? Because I don't have a remainder of 0, I have a remainder of 3. So because 7 doesn't divide evenly into 150, it's not a factor. So on the front of the notes booklet here we have polynomial long division, and the process, the algorithm, is very much the same as when we divide integers when we're dividing polynomials. So the value that we're going to divide into, the dividend, that's written underneath of the division symbol. What we want to divide by is the divisor, that's written out front, so x plus 2 is the divisor. And when we want to do that algorithm to divide x plus 2 into 2x squared plus 7x plus 6, I'm going to focus my attention on the first term in each polynomial and ask myself, what do I multiply times x to get 2x squared, right? I'm asking myself, like I did in this integer division, right, what do I multiply times 2 to get as close to 15 as possible evenly, right, without going over? So that's what I'm looking at here. What do I multiply times x to get as close to 2x squared as possible without going over? And the answer is 2x. So I'm going to write that result in the x column of my place values, right? So now I have a 2x up here in my quotient, and I'm going to distribute when I multiply. So 2x times x in my divisor is 2x squared. Okay, then 2x times the constant in my divisor, that's a positive, positive 4x. Okay, then I'm going to draw a line, and I have to subtract this 2x squared plus 4 from the dividend to continue that algorithm. So this negative out here, I'm subtracting both the 2x squared and I'm subtracting the 4x, right? I have to distribute that negative. So 2x squared minus 2x squared is 0, so that cancels. Then 7x minus 4x is 3x. Okay, now just like we did with the integer division, we're going to bring down the next term, so that's a positive 6, and then I repeat the steps of that algorithm again. So I ask myself, what do I multiply times x to get 3x? And the answer is 3, and I'm going to put that 3 in the constant's place value in my quotient. So it's a positive 3, so I'm going to put a plus there, and then I'm going to distribute as I multiply. So 3 times x is 3x. Then 3 times positive 2 is a positive 6. I draw a line and I change the sign because I'm going to subtract from the dividend. Then 3x minus 3x is 0. That cancels. 6 minus 6 is also 0. And I don't have any other terms to bring down, so that 0 is my remainder. Okay, that means that my quotient, my solution to this problem, is going to be the quotient 2x plus 3, right? And if I had a remainder other than 0, I would write that as the remainder, as a fraction, remainder over divisor. But because my remainder is 0, it divides evenly, right? And my quotient is just 2x plus 3. Because I have a remainder of 0, that means that this divisor, x plus 2, is a factor of the dividend, 2x squared plus 2x plus 6. So in example 1, okay, we have up at the top here the factor theorem. And that factor theorem just states what we just said. If a term divides evenly into a polynomial, then it is a factor. So this is the same polynomial that we just looked at in the example in the front of the notes. So since my remainder here is 0, I know that x plus 2 was a factor of 2x squared plus 7x plus 6. And the quotient up above is also a factor, right? So when I go to write the polynomial in standard form, the dividend, right, what's underneath of the division symbol, that is my original polynomial. So 2x squared plus 7x plus 6, that's the dividend. Okay, then I can factor that dividend by noticing that my divisor went evenly into the dividend with a remainder of 0. So using the factor theorem, I know that x plus 2 was a factor, and the quotient is the other factor, 2x plus 3, right? So that product, the quotient times the divisor, is equal to the dividend when the remainder is 0. Okay, now in step C, to solve the polynomial to find the real zeros, I would set each factor equal to 0, like we did in the last section. So x plus 2 equals 0. I subtract 2 from both sides, and x equals -2 would be one of my zeros. Then my second factor, 2x plus 3, I set that equal to 0. I would subtract 3 from both sides, and 2x is equal to -3. Divide both sides by 2, and x is equal to -3 over 2. That would be my second. So when I go to graph these two zeros and my polynomial 2x squared plus 7x plus 6, I need to go to my x-axis, and I'll have tick marks at -2 and -1. There is a cross at -2 because my factor is linear. And then -3 over 2, that's -1.5. So there would be my second 0, and it's also going to cross there. The leading coefficient is positive and the degree is even, so I know my end behavior is going to be both ends pointing up, and this will then make a parabola or a U-shaped graph. That's a little rickety, but you got the idea. So my parabola is opening up and passing through x-intercepts at -2 and -3/2. Okay, so if you would try this problem on your own, you're going to, in A, write the polynomial in standard form. In B, factor it completely by looking at the work. So this division problem has already been done for you. There's no mistakes in it. All you have to do is just analyze the divisor, the quotient, the dividend, the remainder, and answer the prompts here. So standard form, factored form, then solve to find all the zeros by setting each zero or each factor equal to 0. And then make a sketch of the graph. So pause the video, give those a try, and then when you're ready to check, we'll resume. Okay, so in A, we wanted to write the polynomial in standard form. That is the dividend. So y equals x cubed minus 3x squared minus x plus 3. That is standard form. Okay, then in part B, we're asked to factor the polynomial completely. And since the remainder is 0, the factor theorem tells us that x minus 1 is a factor. Okay, another factor then would be our quotient, x squared minus 2x minus 3, but we don't know if that's factored completely. So to review from Algebra 2, if I want to factor x squared minus 2x minus 3, one of the ways you can do that is with a crisscross, and we put the constant in the top and then the linear term in the bottom. So I'm looking for factors of -3 that add to equal -2, and those factors would be -3 and +1. They multiply to be -3, they add to equal -2. So the factors of x squared minus 2x minus 3 would be x minus 3 and x plus 1. So the completely factored form is x minus 1 times the quantity x minus 3 times the quantity x plus 1. Okay, then to solve the polynomial to find all zeros, I set each of those factors one at a time equal to 0 and solve for x. So x equals 1, x equals 3, x equals -1. These are all crosses on the graph. I have an odd degree, so my ends go in different directions, and the positive leading coefficient means it's going to start down on the left and end up on the right. And that would be my graph then. Notice my end behavior as x approaches -infinity, y is going to -infinity. As x approaches +infinity on the right, y is going up to +infinity.